A pleasant day to everyone. I am Klyonne Campos, your teacher in modern geometry. So before I introduce you about our new topic, let's first answer the activity which leads you to the title and an idea about our topic for today. So get some pieces of paper and answer this activity. So our activity is all about guess me. In order to complete this title, you should think and your answer should be based in the pictures above. So the timer starts now. Okay, time's up. Take a picture to your answers and send it to our Google Classroom. So as you can see, these pictures are related to the title. So this picture is Augustus de Morgan, which is the two words will be the Morgans. Next, this picture is about law. So the third word will be law. Then the next picture is about logic, which is the answer of the fourth word. So our topic for today is De Morgan's law of logic. The fourth picture is the word negation, which is used in De Morgan's law of logic. So what is negation? Negation is changing the positive to negative or changing the negative to positive. So, logic is a study of a formal reasoning based upon statements or proportion. So, our topic for today is all about De Morgan's law for logic. So, before we tackle about what is the law of De Morgan for logic, let us know first who is De Morgan's or Augustus de Morgan. He is Augustus de Morgan. He is an English mathematician and logician whose major contribution to the study of logic include the formulation of De Morgan's law, which is our topic for today, and work leading to the development of the theory of relations and the rise of modern symbolic or mathematical logic. Augustus de Morgan's first work was Elements of Arithmetic, which is in 1930 was distinguished by a simple yet true philosophical treatment of the ideas of numbers and magnitude. And in 1838, Augustus de Morgan introduced and defined the term mathematical induction. Mathematical induction is under in the number theory. Mathematical induction is to describe the process that until then had been used with little clarity in mathematical proof. So mathematical induction is a technique that used to prove the statement, formula, or a theorem that is through every natural number. So, Augustus de Morgans was among two Cambridge mathematicians who recognized the purely symbolic nature of algebra, and he was aware of the possibility of algebras that differ from ordinary algebra. Next, in his trigonometry and double algebra in 1849, he gave a geometric interpretation of the properties of complex numbers, numbers involving a term with a factor of the square root of -1 that suggested the idea of quaternions. Next, he made a useful mathematical symbolism by proposing the use of the solidus or oblique stroke for the printing of fractions. The laws that bear his name was a pair of dually related theorems that make possible the transformation of statements and formulas into alternate and often more convenient form. Now let's discuss the De Morgan's laws for logic. So, the negation or contradictory of a disjunction is equal to the conjunction of the negation of the alternates. Example, as this is a statement. P is the statement 1 and Q is the statement 2. So, if the statement starts with negative, which is not is a negative, so it equals to not P or Q is equal to not P and not Q. So this would be the first law. Not P or Q is equal to not P and not Q. So the negation of not P or Q, it's because not is distributed to first statement and then the second statement. So that's why it becomes not P and not Q. The statement uses or, and in the negation will be and because the negation of or is and the negation of and will be or. So if the statement uses or, therefore the negation will be and. So this is the example of symbolic form. So this symbol will be the not, and P and Q will be the first statements and second statement. The symbol of or will be this one and equal to not P. This will be the symbol of and, which is the negation of or will be and. So this is the symbol. So then the not Q. So not P, then not Q will be not P and not Q. So this would be the same as these statements. The next law is the negation of a conjunction is equal to the disjunction of the negation of the original conjunction. In this statement, not P and Q is equal to not P or not Q. As I said earlier, the negation of and will be or. So this would be the difference of the two laws. In the first equation, they are using or, And the second equation will be using and. So, therefore, not P and Q is equal to not P or not Q. Then, this would be also the symbolic form of this second law of De Morgan's law for logic. So, not P and Q is equal to not P or not Q. Now, let's move to the examples of the De Morgan's law for logic. So, example statements with and. So, for example, I want to buy Coke float and French fries in Jollibee. This would be the first statement and this would be the second statement. The first statement, as you can see, as well as in the second statement, doesn't have negative or the word not, cannot, wouldn't, or etc. So, I want to buy Coke float. The word and, the negation of and is or. So, French fries in Jollibee. So, the negation of this statement will be I don't want to buy Coke float or I don't want to buy French fries in Jollibee. The P statement doesn't have negative, so the negation of positive will be negative. So this statement will be the negation of this statement. So the P will be I don't want to buy Coke float. As you can see, the first statement don't have negative or not sign. So, and then as you can see, the negation of and is or. And then the second statement will be French fries in Jollibee. As you can see also, this statement doesn't have not or negative. Therefore, in negation of this Q statement will be I don't want to buy French fries in Jollibee. As you observe, in the statement, if the two of this statement doesn't have not or negative, the both statement in negation will be negative. Next example will be all students do homeworks in the evening and I do not. This would be the first statement which let it be as P, and the second statement I do not. As you can see, in the first statement doesn't have negative or the word not, so therefore the negation of this statement would be negative. The negation of and will be or. As you can see, to the second statement, the statement has negative or has not. Therefore, in the negation of this second statement will be positive. So therefore, the negation of the statement all students do homeworks in the evening and I do not will be some students do not do homeworks in the evening or I do. Other example statement, the first has it is not true. Zamboanga Sibugay and Zamboanga City are located in eastern part of Mindanao. So as you can see to the statement, it has negative which is not. So, it is not true that Zamboanga Sibugay and Zamboanga City are located in eastern part of Mindanao. So, by using and, the two statement will be negative. As you can see, the first statement has a negative. Therefore, also the second statement will be negative. So, the negation of this statement, it is not true that Zamboanga Sibugay and Zamboanga City are located in eastern part of Mindanao will be either Zamboanga Sibugay is not located in eastern part of Mindanao or Zamboanga City is not located in eastern part of Mindanao. As you see, I uses not, same as here. Even the negation of not is true, but in this statement, it would be like this symbolic form, or not true will be the not and here, and A and B will be this statement. Zamboanga Sibugay and Zamboanga Sibugay are located in part of the Mindanao. So, as I discussed earlier, distributing the negative to the first and second statement will be not A or not B. So therefore, the negation of this statement would be either Zamboanga Sibugay is not located in eastern part of Mindanao or Zamboanga City is not located in eastern part of Mindanao. So the negation of and would be or. The first law of De Morgan's laws of logic has or with or. And the second is with and. Example of a statement with or. So, I don't like chocolate flavor or vanilla flavor. In this statement, both of them are negative for having the first equation has don't or. Therefore, the negation of this statement will be I like, which is the negation of don't, which is positive. So, I like chocolate flavor and I like vanilla flavor. Next is I didn't eat the cake or I did not eat the ice cream. In this first statement, as you see, it has negative as well as the second statement has also negative, which is not and didn't. Therefore, the negation will be I ate the cake and I ate the ice cream. As you can see, the negation of or will be and the negation of didn't, which is negative, will be the positive I ate the cake. And the negation of did not or not will also becomes positive. Therefore, I ate the ice cream. There's no other question. Let us proceed to your assignment. Just screenshot and pass it to the classroom next week. So, this will be try me. So, open your cam again to have a documentation to our class today. And that's all. Thank you for listening.